Hi, today you guys are going to do a lab about cnidarians. And once you finish this intro video, you're going to open up the Google form that says Cnidarian Lab, read through the introduction about sea anemones, and you're going to answer the question about what that part of the lab might be studying and how sea anemones feed. Then you're going to watch a video that I made of sea anemones feeding, and the video is down below the question, so you'll be watching this video. There'll be a screen that comes up that says pause and record your answer, and you go up and say whether the anemone looks like it was grabbing, moving away, had no reaction, closes up, or you really couldn't tell. And then after that, there's a few follow-up questions about what you saw. And then you have to answer all of those questions and go on to the next section, and the next section will be taking a look at the same products plus a couple underneath the microscope. And when we look at them underneath the microscope, there'll be a video attached there. Same idea. Watch the video, pause, move up, and answer your question. And then there's some follow up questions after it. Then, when you're done with that section, you're going to move on to a third section that has a short little video about Cassiopeia, the upside down jellyfish, and how they feed. And then you hit the submit button and you will be all done. Should take you about 30 to 40 minutes. Have fun. Hi, guys. I know it's not the same as dealing with the animals firsthand, but I'm going to put together a lab for you guys dealing with cnidarians, where I've collected some frilled anemones, some young lion's mane jellyfish, and I grabbed some of our upside down jellies from the classroom to be able to give you guys an idea of some of the diversity of cnidarians. So follow along and see what we're going to do with them and answer the questions as you go. See ya. So here's a model of an anemone. We're not going to cut one open, but we can take a look at the model for some of the structures. We've got the tentacles, you've got the epidermis on the outside, the gastrodermis with septa, these folds which increase surface area for digestion, and then the mesoglea, the squishy part of all cnidarians that is just a protein that they secrete. And then in the bottom of the anemone, we've got these digestive threads called acantia threads, which some of them are able to shoot out through pores in their skin to use as defense. And I'm going to collect some of those. I'm going to collect some tentacles. I'm going to take a look at the reaction of them to different materials that we put on them. We're also going to use some jellyfish tentacles, and we're going to take a look at a special jellyfish called Cassiopeia, the upside down jelly. Hi. Another example of cnidarians are our corals, and I've got 3 examples of corals here. I've got an individual coral, which is this mushroom coral, which is a huge coral polyp, and you can see the size of my hand compared to it. These lines here are called septa, and the mouth would have been folded down in here with the gastrovascular cavity basically being the whole thing. Um, so if you think of a sea anemone, and we saw the model of the inside of the sea anemone, it's now sitting on top of this skeleton, and that's basically a mushroom coral. Then the next level is where the individual polyp, which would have been sitting in this little curve right here, develops its calyx and then clones itself, and its clones grow in the next door to it, and they all together make this big coral head, and they would have had this tissue that connected them and made them all one big colony. Another colonial one is this Acropora, which is a branching coral, and you can see the tiny little calyxes on here, but each of them has got tiny little septa inside of them as well. And this would be a couple hundred polyps altogether making this coral colony here. We don't have any live corals to take a look at today, but these are the coral skeletons. They make up the base of the reef. They can be hundreds of feet thick and then just have one living layer of coral living over the surface of it and thousands of years old. 25% of the diversity of the ocean lives in coral reefs. Very important to our survival in terms of oxygen production and CO2 capture. And we know that our warming of the oceans and other impacts on the ocean are creating issues for corals where our coral reefs are under some real serious stress if we don't change what we're doing. But these are the coral skeletons, and that's all we've got for coral today.